Today we're going to begin Chapter 5, so in Section 5.1 we're going to be talking about solving linear inequalities using addition and subtraction. This is going to be very similar to us solving equations as far as the properties that we use. The only difference here when we're talking about inequalities, it's going to contain a symbol that is not an equal sign, and it's going to have more than one answer. So we need to make sure we know which ones are which here. This symbol that is listed first is less than. If you look like a crooked L kind of, that's the less than symbol, and this one here is greater than. Okay, so make sure we know the difference between those two. If it has the line underneath it like these do, okay, that would be less than or equal to, and greater than or equal to. If you ever forget which ones are which, there is a poster over on the wall where it says the algebra symbols. You could find it under there. So the first thing we're talking about is the addition property. If the same number is added to each side, then the resulting inequality is true. This is the same thing that we did for equations, so this should be pretty simple. The goal is still to isolate the x value. So if I have x minus 12 is greater than or equal to 8. Okay, my goal is to figure out what x is, so I need to cancel out my minus 12. I'm trying to isolate this right here. So I can add 12 to both sides, just like I could if it said an equals. So I can get rid of that and make it x is greater than or equal to 20. Okay. Now when you check your solution, you plug it back in here. Okay. You can plug 20 in for x and make it 20 minus 12. And as long as that solution is greater than or equal to 8, then it's true. So 20 minus 12 is 8. Okay. 8 is equal to 8, so it's greater than or equal to. So as long as it's one of those things, it's fine. So it checks out, and then that answer is correct. Same thing over here. If you have 22 is greater than m minus 8, you can add 8 to both sides to isolate your m. So plus 8 here and here. When you cancel that out, you have 22 plus 8 is 30. Is greater than m. Now, one thing that I will point out to you is that sometimes it's a little bit easier to understand what it's saying if the variable's on the left side. This is saying that 30 is greater than anything that m could be. So 30 is bigger than all the things that m could be, or m is less than 30. So 29, 28, and so on. Okay, so if you want to reverse the order of the inequality, okay, you can switch where m and 30 are, as long as you also switch the inequality sign, okay, so that it's still pointing at the same side. So it was pointing at m to start with, so it's going to be pointing at m here. Either one of these answers is correct, but sometimes it's a little easier to understand in this scenario here. Okay, and you can go from there. Okay. So if you want to do these two examples, you're welcome to. I'm going to go ahead and move on to the next part, but you're welcome to pause and work those out and see what you get. So one of the ways that they'll write this is in what we call set builder notation, which is basically a more concise way of writing a solution set. So it's saying that x can be all of these things. You can also graph these on a number line, and if the endpoint is included in the solution set, you want a closed dot. If the endpoint is not included in the solution set, then you want an open dot or an open circle. So if I was going to graph this one here, my point is going to depend on what the solution is, in this case -5, and also looking at this inequality. If it's included, that means it's saying it's equal to. Okay, so at -5, I'm going to put a point, and it's going to be a closed point. Okay, closed point here because it was included in the solution set or it was equal to. Okay, now if it's saying that x is greater than or equal to -5, I want to talk about the values that are bigger or equal to -5, which is all of these numbers that are going in this direction. So I'm going to draw my line going that way and say that it's all of those numbers over there. That's the main difference between an inequality and an equation, is an equation just has one answer and an inequality is talking about a set of numbers. Okay. We can also do this with the subtraction property. So if the same number is subtracted from both sides, then we can still have a true inequality. So we're going to also practice writing the set builder notation. So whenever we're looking at this, if it's m plus 19 is greater than 56, okay, I'm going to subtract 19 because, again, the goal is isolate m. When I do this, I'm going to have m is greater than 56 minus 19. If you wanted to subtract that, that's going to give you 37. Okay, and then this would be your answer. Now if I write that in set builder notation, first thing you list is the variable, which in this case is m, okay, and then this double line kind of separates what's our variable from what's happening, which in this case is that m has to be greater than 37. Okay. Now they didn't ask you to graph this, but if you were going to, this would be an example of one that has an open circle because of the inequality right here. It's just saying that m is greater than 37. It can't actually equal 37, but we'll do some graphing ones here in just a second. The next one, p plus 8 is less than or equal to 18. I'm going to isolate p by subtracting 8 from both sides. When I do that, I'm just left with p over here, less than or equal to 18 minus 8 is 10. And if I wrote that in set builder notation, it goes in the braces, list what my variable is, and then list what's happening. Okay. So p is our variable, and all the values for p have to be less than or equal to 10, so it can be 10, 9, 8, 7, also decimals and fractions, etc. Now, you might also run into situations where you have variables on each side. We're going to solve these just like we did whenever we had variables on both sides for equations. We want them to be on the same side so then we can solve, and then we're actually going to practice graphing. So 3a plus 6 is less than or equal to 4a. I'm going to subtract 3a because that's the smaller one of the two, and also because I want a on an opposite side. So 3a minus 3a is gone. I'm still left with a positive 6, and then 4a minus 3a is a. Now, if you wanted to do that reversal, you can. Okay, this is saying that 6 is less than or equal to anything a could be, or a is greater than or equal to 6. These two things are the same thing. Okay, sometimes it's a little easier to graph if you have a better understanding with the variable on the left side. So we're going to look at what our number is, in this case 6. I'm going to find that on my number line. And then I'm going to look at my symbol, which in this case is equal to. Anytime we have an equal to, we are doing a closed circle on our number line because it's including it. It can be equal to 6 or anything that's bigger than 6. Now, the numbers that I want to choose are the values that are greater than or equal to 6. So your options are to go to the left towards 5, 4, 3, 2, and 1, or to go to the right towards 7, 8, 9, and 10. The values that are greater than 6 would be these values going this way. That's the way that I'm going to draw my line. Now, same thing for this next one. Okay, I have variables on both sides. So I'm going to look at 9 in and 10 in, and I'm going to cancel 9 in out to the other side. That will cancel and leave me with negative 1 is less than 1 in, or just 10. And again, you're welcome to flip that around. Okay, switch the n and negative 1, but then also make sure that the that the symbol continues to point at the same thing. So you're also going to flip the symbol around. Now, this is an example of one where they're saying n has to be greater than negative 1. It can't actually be negative 1. So my point is at negative 1, but it's open this time. So it's going to look like that. And that's basically saying we can go all the way up to negative 1, but it can actually be that. So n is greater than negative 1. I need to choose all the values that are bigger than negative 1. So I have my options to the left are negative 2, negative 3, negative 4, and so on, or 0, 1, 2, 3, 4, 5. The values that are greater than negative 1 are going to be going this way, so that's the way I'm going to draw my line. Make sure we're putting arrows on the number line, or on the line that we're drawing on our number line, because it is continuing on forever. All of those numbers are greater than negative 1. So if you want to do some practice here, you're welcome to solve the inequality. You can practice the set builder notation, and then you can graph. If you look on a completed copy of the notes, you can see what the answer is for this, so you can look at that. On the last part here, these are some of the phrases that you might see used for inequalities, besides the normal, less than, greater than, things like that. So obviously this first one here is the less than symbol. Okay, this is obviously, we know it as less than, but sometimes they like to use fewer than. Okay, so if you ever see fewer than in the word problem, that's talking about less. We have the greater than symbol, or what they like to call more than sometimes. Less than or equal to, sometimes that means at most or no more than. Okay, you can have no more than $5, that means you have less than or equal to that amount. Okay, greater than or equal to is also known as at least or no less than. So if I have to have at least $10 to go, I can have no less than $10. I have to have $10 minimum. So those are the different words that you might see for that. Okay. The last thing we're going to look here is a word problem. Okay, it says Felipe needs for the temperature of his gecko's basking spot to be at least 82 degrees. Okay, so that at least, if you go back and look here, that meant that it was greater than or equal to. Okay, so I'm just going to make a note of that here. Currently the basking spot is 62.5. How much warmer does the basking spot need to be? So I need to figure out how much more does he need to add to 62.5 to figure out how to get to that minimum of 82 degrees. Okay, so I'm going to take the value I'm trying to find plus the 62.5 degrees that's already in there. And I'm going to compare that to the 82 degrees that I want using greater than or equal to because of that at least. Now if I wanted to simplify this, I would subtract the 62.5. So when I cancel that, okay, I'm going to be able to figure out what that is. I did not bring my calculator with me. Let's do some easy math here. 19.5. So the minimum that I can add to my temperature is 19.5 degrees. How much more warmer does it need to be? It has to be greater than or equal to 19.5 degrees. Okay, 19.5 would be the minimum. Okay, it could be 20 degrees, 21 degrees, and so on. But that is how that is going to be set up. So make sure you refer back to this chart if you need to figure out which of the symbols you're supposed to use. Okay. So you have 14 questions that you're going to do. Make sure you pay attention to what the directions are asking as far as set builder notation and as far as drawing the number line. It should explain it all for you so you know exactly what it is that you are supposed to do. Okay. Have a good day.